electricity is something, remember that electricity is, okay, so electricity is flow of electrons. Okay, flow of electrons. Okay, so how electrons flow, it is known as electricity. Suppose that we know that we are very much aware of electricity, and all our natural appliances like TV, fridge, light, all of them are get conducted by electricity. Okay, so these devices are based on electricity. So electricity is a very good form of energy, very good form of energy. Okay, I'm going to relate this with magnetic effect. I'm just giving you idea of electricity. I'm not going to tell you this in detail. First of I will give you idea of electricity, and after that we will study about magnetic effect of electric current because electricity. Okay, so just think that first of all I'm going to tell you that each and everyone know that this bulb glows only because of electricity. This bulb glows only because of electricity, and without electricity this bulb is not able to glow. So electricity is very simple form of energy, and we can produce this energy from two sources. We can produce this energy from two sources. It is very cheap source of energy, first of all. Okay, why this is cheap? Because you know each and everyone can afford this. Second, I'm going to tell you that electricity is the form which is produced by several type of sources. Like we can make electricity from wind energy. Okay, we can make electricity from solar energy. If we can make electricity from sun, we can make electricity from wind. Okay, we can make electricity from water. Okay, so these are some natural sources by which we can make electricity, and these two are some artificial sources by which we can make electricity. So we can make electricity by this cell. We know this cell. Okay, so in this cell, all of us are aware of this. You have seen this very uh, closely, and we know about these cells. So these cells have two terminal, positive and negative. Okay, now this is of much important. Everyone, if you are not aware of this, then after this class, see your battery from your remote controls or any other appliance, and this cell is having two terminal, positive terminal and negative terminal. Remember this. This is of much importance. Okay, so these terminals are also known as poles. Okay, in magnetic effect I will tell you about poles. So there are two poles. Okay, and I will inform you about the name of these poles. One pole is known as south pole and one pole is known as north pole accordingly, but these two are known as, they will be considered as poles. And this will form, these are chemical sources which will form electricity. Okay, and these are mechanical source. This is generator. Okay, you have seen these generators so many times, and by using physical force, okay, by using physical force we can make electricity out of this. Okay, so these are chemical sources of electricity, okay, cell, and these are physical sources of electricity. Now what are the advantages of electricity over other type of energy sources? That they are clean. That means electricity never forms uh, uh, ashes, and it never creates pollution. Okay, never it forms ash content. Okay, they are flexible. Flexible means that we can use any appliance like bulb and fan, where they are very small appliances. We can charge our phone batteries and laptops by this. So they are very small appliances, and we can use small appliances. Same time we can use small appliances which need much energy. So sometimes we use appliances which need less electricity, and sometime we need appliances which need more electricity. Okay, so some appliances which need more less electricity, these appliances are bulb, phone. Okay, sometime we charges our phone, and more electricity like our geysers. Okay, refrigerator. Okay, they are much efficient. Efficiency means they can regulate, or they can conduct, or they can make work any type of appliance. Any type of appliance can be, they are highly efficient, and they can be used with any type of appliance. So can flexibility means we can use much amount of this electricity, and we can use less amount of electricity same time. And efficiency means they can use they are very efficient, and they can run many type of appliances. And easier transmission, the meaning of easier transmission is, you can see that these are wires, and a wire which is less than 1 inch thick, less than 1 inch thick, okay, it can conduct electricity. We know the sources, that how this can be transported. Okay, now remember that electricity, this is our atom. Okay, or I'm just giving you an idea of electricity, and just after that I will start magnetic effect. Okay, this is our wire. Okay, now we are having two type of material in our daily life. One material is known as conductor, and one material is known as insulator. Conductors can conduct electricity because they can give electron, and insulators cannot conduct electricity because they cannot give electron. Okay, what does it mean? It means that, suppose this is a wire. Okay, this is a wire of metal. I'm using copper wire. Okay, and this is a wire again, and this is wire is made up of non-metal, and this wire is made up of plastic. Okay, so we know that each and everything which is made up of atom. Okay, so I'm telling you about this atom. This is atom. Okay, and we know that these atoms have shells. Okay, shells, do you remember the shells known as K, L, M, N? K, L, K, L, and M. Okay, so these are shells, and each and every shell, it is filled with electrons. And this one. Okay, so I draw sodium, and it is a metal. Okay, so this is a sodium atom. Okay, and it is having electrons. Now, by any method, if I, by using any type of method, okay, if I am able to do something, if I am able to do something, that if I use a force, I can use any type of force. Okay, I can use, what type of force I can use? I can use wind force, I can use solar force, or I can use water. I can use a force, and by this force I will use this force to strike to this atom, and by this striking, this extra electron, because we know, what do we know? That electron is present in this shells. In K shell there is 2 electron, in L shell there is 8 electron, in M shell there is only 1 electron. So by using a force, I'm giving force to this particular this atom, and this electron which is present in outermost shell. Okay, by using my force, okay, I'm using any type of force. If I use that amount of force, or if I use that type of force or that magnitude of force that if I will make this atom to come out from this shell. Okay, now this atom will come out from this shell. Okay, so why this atom is able to come out from this shell? Because this atom, this metal can give this atom, only metals can give this. So if I'm using this with copper metal, or I can use any metal, all of them having electrons in their outermost shell. Okay, they are having electrons in their outermost shell. So I provided a force, or I provided a jerk, or I provided any type of magnitude of force which allowed this electron to come out. So electron from each atom will come out if I give a particular amount of force. So electron will move out. Okay, electrons are out. Electrons are out. These electrons are out. Okay, so these electrons are out, and this electron will start moving randomly. Some will go here, some will go here, some will go here, some electron will go here. So electrons will come out and they will start moving here and there. Okay, so this is not a correct way. So in this type of metal, electrons will come out. Okay, electrons will come out because I provided a force. I provided a force and which allowed the electrons to come out. Okay, but now the electrons are moving here and there whatever they want. Okay, whenever they want. So this is a surface. This is a area. Suppose I cut this wire, or this is the area. So some electrons are moving here and some electrons are moving here. Okay, the amount of electrons are moving here to here, and some electrons are moving here to here because they are having random way and they can move, because I just gave a jerk, I just gave a force to it, and all the electrons came out. This electron, there are so many type of atom and all electrons came out. Okay, all electrons from outermost shell came out, and now they are moving here and there whatever they want. Okay, according to whatever they want. Now if I manage, anyhow if I manage this electron to follow in such a way, I manage that these electrons will use a method that if I use jerk, this electron will definitely come out, but this electron will move to here. Okay, now this electron number 1 came to this atom. Okay, now this electron will give jerk or pressure to this atom, and the electron which was present inside it will come out and go to inside. So this is atom number 1, this is atom number 2, atom number 3, atom number 4, atom number 5, atom number 6, and so on. So I provided a force of a specific magnitude, and the atom number first removed its electron, and this electron number 1 goes to atom number 2. Okay, now this atom number 2 is also having electron in its outermost shell. So by it, that electron number 1 give a jerk, or it will again pressurize this atom, this electron, and this electron will go to here. Okay, now it is this atom number 3 is also having electron, so it will go to here. So it will have electron of atom number 3, and it is having its own electron, it will go to here. Okay, now it will come here, and electron which is present in outermost shell of atom number 5, it will go to here. So it will here. Okay, now electron number 6 will go to here. So this is how electrons will move from one atom to another atom. So I just provided a jerk, and electrons are moving in this way from one atom to another atom. Okay, so electron from here will go here, it is stabilized here. Electron from here to go here, it will stabilize here. The electron, another electron from here to here they will move in such a fashion, or they will move in such a fashion or in a way that now they are not moving randomly, that someone is moving here and someone is moving here. No, definitely now if I use this area, definitely I know that electrons are moving in this direction. So first of all, the need is to provide a specific jerk or specific force to let the electron come out. Okay, so let the electron come out, electron will come out. And second duty is to make them flow in a current. Okay, so they will flow in a current. How they will flow? They will flow in current like manner, in this manner. Okay, so the electron will move from one atom to another atom. And now if I want to calculate, then I will say the electron which are moving from this surface, the electron which are moving from this surface, electron is equal to, I don't know number, but I will definitely have a number. And electron which are moving from here to here are zero. So there is only one path that electrons are moving from here to here, definitely in a number. And electron which are moving to from here to here are zero, but here to here definitely a path, and they will form a current. That's why electricity is also known as electricity is also known as electric current or current of electrons. Current of electrons. Okay, so this was our electricity. And definitely there are in an atom you can find. Okay, tell me that if this thing is clear to you, that how electrons move. How electrons move. Tell me if this thing is okay with you, or if you are able to understand this. Can you explain how electric current flows? Okay. Listen, tell me how electrons flow. They don't flow they should not flow in random manner. They have to flow in just a single direction, so that you can say they are in current. Okay, in this case there is no current. Some will flow here to here and some will flow here to here, so there is definitely no current. They can move here to here and they can move here to here, but in this direction they are moving. Only they are having, or they acquired a single direction or single place to move. This is known as current. Okay, now again I'm going to tell you about two things, that there are two type of charges. One is positive charge and one is negative charge. Okay, so this is our atom and it is having electrons. Okay, and outermost electron can conduct electricity. Okay, only outermost electron can conduct electricity. The other electrons which are present in this shell, the other electrons which are present in shell cannot conduct electricity because they cannot go outside. So right now I'm using example. This is my copper atom. Okay, this is my copper atom, and this is the shells of copper atom K, L and M. Okay, these are shells. So if anyhow I make a jerk and I make this outermost atom to come out, okay, then if I make sure that all these atoms which come out will move in a particular direction, so I can say that this is my electric current. Okay, so there are two type of charges, positive charge and negative charges. So electron having negative charge, and the most important thing, proton, which is having positive charge. Okay, so there, and neutron is neutral, there is no charge. So the direction is there are two type of charges, positive charge and negative charges. So just you have to remember that there are, this is the, if this is the direction of negative charge, then definitely this is the direction of positive charge. Just you have to remember this, that if this is the direction of positive charge or electron, then this will be direction of negative charge. So these two charges, how definitely proton never moves anywhere, but this is conventional direction, or we can say that current is carried by current is carried by negative charges, which are electrons. Okay, now I'm going to start your chapter, which is known as magnetic effect of current, and this is very useful chapter. Magnetic effect of current. Okay, so if you are done with electricity, now I'm going to tell you magnetic effect of current. Now, what is magnetic effect of current? First of all, let me tell you one thing, that okay, Faizan, are you aware of resistance and is these things? Tell me if you are aware of what is resistance in these things, so that it will be easier for us to understand. If you know that what is resistance. Okay, so this is magnetic effect of current. Okay, now in this case, what is current? The flow of electron is known as current. Okay, now electron will flow. How electron will flow? Electron will flow like this, from one atom to another atom. They just jump. The older atom which attacks this atom will remain here, and the atom from this will move. So this is just moving of atom from one atom to another atom, just electrons move. So this is known as current. Okay, now first of all, uh, remember that this is a battery, and this battery is having positive and negative terminal. Okay, so this is our circuit, and in this circuit it is our battery. Okay, so it is positive and it is negative. So this positive terminal, consider this positive terminal as south pole. Okay, remember that this positive terminal is south pole and this negative terminal is north pole. Okay, so it will help you to understand that how electricity move. Okay, so I'm just drawing again this is our electric circuit. This is positive, this is negative. Positive pole is south pole. You have faced so many problems related to this, and this is our north pole. Now in this circuit, this is resistance, this is ammeter, and this is how our circuit is complete. Okay, and definitely if you want to put a key, you can put a key. So resistance, that will hinder, or it will not allow electricity to flow. Okay, now remember that how electricity moves. Electricity moves from positive to negative. We know that electricity move from positive to negative. Okay, it will move like this. So it means that electricity moves from south pole to north pole. Okay, so electricity moves from south pole to north pole. Okay, why I'm telling you this? Because you will face so many type of problem, that how electricity moves. So it will from this to this. So in this side, the direction of flow of electron or electricity is like this. Okay, if I'm using another circuit, you can use this. This circuit is I'm using from our book. Okay, whatever you want to put inside it, you can use a key, or whatever you can use resistance. So this is positive, this is negative. That means this is a south pole and this is a north pole. Okay, so how elect moves, it will move like this. Okay, so in this direction electricity moves like this. Okay, now in same case, we are having an activity, and this activity you have two terminals, or our author make 2 points. First point is known as X point, and another point is Y point. Okay, and here it is used a cardboard. What is the cardboard? it has used this. Okay, so this is we can say copper, sorry, this is copper wire. Okay, and here I am using a compass. Okay, this is compass. Okay, so this is compass, and I will tell you, inform you about this compass in our next class. So compass has a needle. Okay, this compass has a needle, and this needle always deflect or move. This needle always move toward the direction of current. Okay, so here we can see how this is, how is the direction of our current. This is the direction of our current. Okay, so here I'm using this compass needle, and the direction of our current is from this pole to this pole. The direction is like this. Okay, so the it always show north pole. Okay, here just our we are, what we are going to do, just we are going to understand that how the direction of current changes. So in this case we are going to understand the direction of current. Okay, now look at this. Okay, here I'm using this, and the current direction of current is like this. It is going towards like this. Okay, so the compass needle, where whatever the direction of needle I'm placing, it will move toward this side. Okay, it will move toward this side. Suppose if I use this compass needle and I place this compass needle in this direction before, but it will move toward this side. Okay, because it get affected by the movement of electrons. Okay, but in second case I'm using this, and look at this. Now I'm just changing the direction. Okay, I'm changing the direction. So now this is my positive pole and this is negative pole. So this is known as south pole and this is known as north pole. And the direction of flow will be like this. Okay. Now again, I'm using a cardboard and putting a needle on it. Sorry, a compass on it. Okay. Now again, there are 2 points, point number X and point number Y. Point number X and point number Y. Okay, now in first case the direction of current is from here to here, and in second case the direction of current is from here to here. Look, in first case it was here to here, and in second case it was here to here. Just because how I use this cell and how I arranged this cell, the poles are changed. In this case it is the negative pole, and in this case it is the positive pole. So how I change the pole, as I change the pole, the direction of current also change, because it will go positive to negative. So what happens exactly in this case, the needle will move here. Okay, in first case needle was moved here, needle was here, and in second case the needle is moved here. Okay, so in this case or in these two cases we are not going to learn about that how needle get deflected or in which part needle effect. Needle always show north pole. Okay, definitely in this case we are not going to learn about what poles and what are not poles. I'm just going to indicate you one thing, that the needle in first case is deflected to this side and needle in second case deflected to this side, because in first case the direction of electricity was like this, and in second case the direction of electricity was like this. So as the direction of electricity changes, okay, direction of electricity changes, okay, you can use any direction. Okay, electricity produces some effect. Okay, I will continue this on Monday, that as the direction of this electricity changes or the current is changes. Okay, first it was like this, and second it was like this. So the needle also get deflected, or it will change its direction. The direction of needle will change. Direction of needle change. Okay, so on Monday I will tell you that why it will changing its direction according to a changing of the direction of current. I will tell you on Monday. Okay, tomorrow you are having test and I will give you test paper which you have to submit me. So I will provide you test on WhatsApp. Okay, so I will continue this on Monday, same time and